Good afternoon. Welcome back to my YouTube tutorials for building management system. Okay. Now, before anything else, I would like to say thank you very much for keep on supporting my channel. I do hope you are learning something. If you're a new engineers or newly graduate engineering student, I do hope I will be able to teach you what are in store for you if you will become a BMS engineer, if you will join a building MEP company, mechanical, electrical, and plumbing company. Okay. Now, guys, in my previous tutorial, I already explained about some of the HVAC equipment that you might encounter in a BMS project, like twin exhaust fan or exhaust fan, air handling unit. We discussed about fresh air handling unit or FAHU, the recirculating air handling unit, then the energy recovery unit. Now today, the scope of this tutorial will be the introduction for another HVAC equipment, specifically the chilled water system. Okay. Now for chilled water system, you can find the basic component there will be chillers. Okay. We have two types of chillers, the reciprocating and air-cooled chillers or water-cooled chillers. Okay, for air-cooled chillers, they will be using these compressors. Okay. Then also for water-cooled chillers, they will be using water to cool the refrigerant. Okay. Now, for bigger application, they are using water-cooled chillers. Okay. Then for small application, they are using these reciprocating compressors for air-cooled chillers. Okay. Now, today I will start discussing the simple heat exchangers and chilled water pumps. Okay. Now, as I said, the basic components for a chilled water system are the chillers and the pumps or the circulating pumps. Okay, so we have primary pumps, we have secondary pumps, we could have also tertiary pumps, we could also have condenser water pumps for water cooled chillers. Okay, now guys, in this graphics, what I have here is my chillers and what I have here is my heat exchanger and three chilled water pumps. Okay. Now, heat exchangers or HECs, the main purpose of this is to cool down the chilled water coming from the building. Okay, so to show you, okay, how it works. Now, as you can see here, I have here a pipeline. One pipe going to building load, then one pipe coming or chilled water coming from the building load. Okay, when I say building load, this could be air handling units, fan coil units, and other HVAC equipment that needs chilled water for cooling the air that needs to be delivered in a area served by the equipment. Okay. Now here, guys, what I have here is the typical control and monitoring points. Okay. Now, as I said, the control for this system, this heat exchangers and chilled water pump, is based on an approved sequence of operation. Now, there could be several sequence of operation, and there could be different arrangement or design for heat exchangers and chilled water pump. Now, these heat exchangers and water pump could be found in our ETS room. ETS, I think that is energy transfer system or setup. Okay. Now, when you say energy transfer, now we have here chilled water coming from our chillers. Okay. So the chilled water will be the one to cool the chilled water coming from the load. Okay. So meaning in this heat exchanger, there will be tubes inside of it. Then the chilled water from the load will be cooled by the chilled water coming from the chillers. Okay, so the output here is the chilled water that will be supplied again to all the HVAC equipment in the area being served. Okay, now actually this kind of setup, maybe you can find it in the middle of a high-rise building. Okay, now actually maybe if you have a 50-story building, maybe you can find this at the middle of the building, okay, wherein the purpose of this chilled water pump is to deliver chilled water requirement up to the farthest air handling unit that needs to be supplied with chilled water, okay? So the chillers, maybe the chillers will be in the basement of the project, okay? So from the basement, there will be another set of pumps that will deliver or push the water to these heat exchangers, okay? Then it will just circulate, okay? Now, I will try to write a control for the pumps, okay? So here, I will not, for a simple control logic program, I will just try to write a control logic program for these three pumps, okay? Now, I will not write a control for the bulbs, okay? Maybe in your project, you will be having several butterfly bulbs that needs to be controlled, okay? But for this simulation, I will just try to write a control logic program for these three pumps. Then I might also write a control logic program in controlling the opening and closing of this butterfly bulbs. Now it depends on the butterfly bulb. If it will be open close or a modulating bulbs, okay? Now as I said, I will just try to write first. I will just try to write a control logic program for these three pumps, okay? Now basically we have these monitoring points, so we will try also to monitor in this system. You need to monitor the temperatures that is going inside from the supply side. Maybe we can say this is the primary side and this will be the secondary side of the heat exchanger. So you need to monitor the temperature changes from the supply and the return to the chiller, and also from the load then going to the load, okay? So for both heat exchanger, you need to monitor the temperatures, okay? Now guys, there is one differential pressure transmitter that will be installed across the main supply and return line going to the building. Now the purpose of this differential pressure transmitter is also to control the speed of the pump, okay? Now if the speed of the pump is varying, you need to use here a variable frequency drive. Then that variable frequency drive, the speed reference will be dictated by the differential pressure transmitter set point here, okay? Now the differential pressure transmitter set point will be given by the mechanical engineer who is in charge in designing this system, okay? So that set point will be the desired output or the speed reference for both of the pumps. Now for the sequence of operation of the pump, there could be several sequence of operation. Maybe I will write my control logic program in a sequence SOP wherein 2 duty, 1 standby. So meaning 2 duty, 2 pumps will try to deliver the necessary chilled water to the load based on the differential pressure set point. Then 1 pump will be duty, okay? Then you will apply also the sequencing, the changeover, the one that we learned from the previous tutorial, how we are going to sequence these 3 pumps, okay? Now again, as I said, it will be your control logic program will be based on an approved sequence of operation, okay? So that will be the scope of the next tutorial. So again, we have also some monitoring points for the pump, okay? So we have here the pump run status for the 3 pumps and the flow. Okay, now for the flow, typically we are using here a differential pressure switch, water type differential pressure switch across the pump, okay? So if there is a differential pressure across the pump, meaning there is a flow of water, okay? So we are using that one to monitor the flow, because maybe the motor of the pump is running, but we are not actually delivering water because maybe there's some problem with the pump's mechanical part, especially the impeller part, okay, which is responsible for delivering water, okay? So now, okay, I don't have here the start stop command, okay? Maybe I can include it also here, no problem. Then also we are going to monitor the run hours of the pump for sequencing purposes. Then we have here our runtime reset, okay? Okay, so again, guys, this is a typical heat exchangers and chilled water pumps, okay? A typical layout. Then I will be in the next tutorial. Please watch for it. I will be trying to simulate this, the operation of this based on a simple control logic program for the pumps. Okay, so guys, I always appreciate your support to my channel, and I do hope I will be able to reach more new engineers who are planning to join the field of building automation or building management system, and also those engineers who are planning to join an MEP company. MEP company is mechanical, electrical, plumbing company that is responsible for installing all the mechanical, electrical, and plumbing requirement of a project. Okay, so if you are planning to join those company, then this tutorial will give you a first hand idea, or give you a bird's eye view. What are the equipment that you might encounter in the field if you are going to join an MEP company? So once again, thank you very much for joining me in this short video tutorial, giving you an introduction to a heat exchangers in chilled water pump. Thank you. And Santos Capilla Jr. will always end the tutorial by saying, God bless us all. Let's all be safe. And bye for now.